This DVD has been produced by the New Zealand Ministry of Health. It provides information on the operation and management of reticulation systems for small drinking water supplies. The benefit of treated and reticulated drinking water is that it provides safe running water to the consumer at the turn of a tap. The decline in waterborne disease over the past century in developed countries is a direct outcome of water treatment. But all water suppliers, including the small water supplier, has the job of not just making water safe to drink, but also making sure that the water remains safe after leaving the water treatment plant until the point of delivery.
A water storage and distribution system is called a reticulation system. This refers to the tanks and pipes used to get water from a treatment plant to a house or building. Often, its component parts include storage tanks, reservoirs, pumps, meters, pipes and backflow prevention valves. But a simple roof tank and the pipes which use gravity to feed to a tap is also a reticulation system. The reticulation system needs to be a safe and secure system of getting water from the treatment plant to the consumer.
Many water treatment plants actually spend less money on the treatment facilities than they do on reticulation systems. But it's often easy to overlook the vulnerability to recontamination of water within the reticulation system. Once the water is clean, we do not want it to be recontaminated. Nearly half of all outbreaks in waterborne disease in the USA between 1995 and 1998 were caused not by problems in the treatment plant, but by deficiencies in the reticulation system.
Ensuring that water remains safe after it leaves the water treatment facility until it gets to the point of delivery is a major challenge. But as a water supplier, your responsibility doesn't end with getting the water clean with treatment processes. It includes making sure it stays clean and safe when it's in the distribution system, keeping it clean until it comes out of the tap.
We just upgraded the treatment plant. We got a new UV unit, a filter system, and then we tested the water and found that we were still getting E. coli in the storage tank. Talk about frustrating. And really, really disappointing too, to find out that as soon as we'd treated it, it was getting contaminated as soon as we'd put it in the tank. After spending all that money, time and effort, I guess I assumed that once the water was clean that it'd stay clean. It turns out that the tank had a sloping roof and the lid didn't fit properly. So the rain was washing the bird poo off the roof into the water that had only just been treated. And the problem was so easy to fix. And we just thought that once we treated the water that our job was finished. It turns out that having a UV system was a waste of time if we just let the water sit there getting contaminated again while it was in storage.
Once the treated water has left the treatment plant, we don't want this water recontaminated. In other words, treated water needs to be protected from any contamination that may allow bacteria, protozoa, viruses to get back into the water.
But recontamination covers more than just recontamination from pathogens. For example, pump equipment should be selected and installed to prevent recontamination by pollutants that might get in the water, like lubricants from the pumps.
Oh good, cool, yeah, okay. Tank vents are a necessary part of the system. They must be covered or screened by a mesh screen. Secure hatches and non-corrosive screens are needed to prevent small animals or birds from entering and recontaminating the water. Overflow pipes also need to be protected from entry by birds and animals. To ensure the reticulation system remains secure, it needs to be regularly maintained. This could include inspections of tank hatches, vents and overflows, and periodic microbiological tests to confirm recontamination hasn't occurred.
Storage facilities are necessary so that the communities they service are provided with enough water for a period of time, at least 24 hours at the average flow rate, in case the supply from the treatment plant is interrupted. If if we were dosing chlorine as a disinfectant, remember reservoirs can also act as a place where contact time with chlorine and inactivation of pathogens occurs.
There are two basic types of storage reservoirs, and the supplier needs to choose which works best for their own particular water source and availability, as well as the needs of the consumer. Ground level storage tanks are excellent for the small supplier and are simple to construct and maintain. These can be constructed on a hill that's high enough to provide adequate system pressure. The size of the reservoir will depend on the peak and average demands. Elevated reservoirs or water towers like this one, which aren't very common in New Zealand, hold water at a height that maintains pressure to the distribution system without a need for continuous pumping.
Construction materials need to be given consideration. A tank with a roof constructed from treated timber, see, look at that, can release arsenic from the timber treatment chemicals into the water, unless the timbers are protected with a robust liner. Asphalt or tar cannot be used for waterproofing the interior of the reservoir because they can chemically contaminate the water.
Rough surfaces or crevices in the walls of reservoirs need to be avoided, as these promote a haven for slimes or biofilms. Biofilms can shield some pathogens from chlorine. And particularly vulnerable are the interface of air and water, scum lines or rings. These are excellent places for pathogens to be masked from residual chlorine in a tank. So tanks need to be inspected regularly and biofilms removed by water blasting.
A top-filling bottom emptying regime is the best way to get residual chlorine circulating and avoiding short-circuiting. Short-circuiting is when water enters the system and then goes straight out, leaving the bulk of the water static.
It's important to choose a site for a storage tank which is still accessible during floods and other hazards, and easy to access for maintenance. Fencing, padlocks, other security measures also need to be thought about. Lids need to have a lip in order to prevent ingress. They also need to be padlocked to keep intruders out.
To get water from one place to another requires water pressure. This can be achieved by using gravity pressure or by artificial pressure created by a pumping system. However, if a poorly selected pump is used, the water pressure may get too high and burst pipes, allowing pathogens into the system. Also, if the power supply fails, the water is interrupted. Fluctuations in water pressure can dislodge biofilm and resuspend any sediments in the pipe, increasing the turbidity of the water.
Water pressure, whether created by pumps or by gravity, need to maintain adequate pressure at the tap. Some pumps have the advantage in that they automatically turn on to maintain water pressure when the pressure drops, for example, when a tap is turned on. Pumping systems should be selected to suit the daily needs of consumers and the layout of the reticulation system being used. Construction materials used in the various components of a reticulation system also need to be given consideration. Alkathene pipes, like these ones for example, are not designed to withstand high pressures. It's also important to choose materials that will not be corroded by water.
Backflow occurs when any water, foreign liquids or other substances flow back into a water system. I'll show you these. Take a look at this. Okay, this can happen because the pressure of the water in the system reduces and sucks the foreign liquid into it. Reverse flows, or backflows, can be created in a number of different ways by a difference in water pressures. This causes water to flow back into the distribution system. That's not a good thing. The negative pressure can be caused by things like mains breaks, inadequate flow, undersized mains, shutdowns for repairs, or the use of online booster pumps.
There are many documented incidents of backflow that have resulted in sickness and sometimes even death. In a situation where the risk of backflow is identified, there are two real choices. Either remove the connection completely or install a method of protection such as a backflow prevention device. The choice of the most appropriate method of backflow prevention depends on the level of risk that is identified. In order of security, the options are an air gap, a reduced pressure backflow preventer, which is 2 spring-loaded check valves with a pressure-regulated relief valve between them, or a double check valve assembly.
Creating an air gap is the least expensive form of backflow prevention. This is when you have airspace between the outlet of the water flowing into the tank and the surface of the water in a tank, just like the cistern in a flush toilet. The air gap prevents the water from flowing uphill and forming a siphon. You can see this demonstrated here. When the water reaches the highest level it can, the tap is above the water. There is an air gap. Now watch the same system, but where the tap is too low or has a pipe or hose attached to it that goes below the rim. There is no air gap and the water pressure in the system reduces. The dirty water from the sink can be siphoned or sucked into the water system.
Last year, one of our pipes burst, so we found out where it was leaking, dug it up with the intention of fixing it. Dug it up, exposed it, and left a hole around it so we could work on it. Now the leak meant that the hole we dug slowly filled up with water, but we thought to ourselves that at least the water that was coming out was clean. What we didn't figure on was that there was a slight drop in water pressure and some of the water in the hole got sucked back into the system, and that water wasn't clean anymore. What's more, as soon as this water got into our tanks, we couldn't guarantee that any of it was clean anymore. A total nightmare. One small backflow prevention device and more care and hygiene during maintenance, we could have saved ourselves a whole lot of headaches. Not to mention stomach aches and diarrhoea.
Maintenance of a water distribution system is necessary to ensure a reliable and safe supply of water. As such, it's very important that high standards of hygiene are upheld during maintenance, otherwise recontamination can occur. Wherever possible, all connections should be made under dry conditions. Dirty piping needs to be thoroughly cleaned and disinfected. Disinfection can be done using a squirt bottle of industrial strength bleach. Squirt the bleach all over and inside the pipe before connections are made. Be careful though, this stuff can burn you badly if it gets on your skin.
Biofilm in pipes needs to be scoured or flushed out from time to time, and the storage tanks should be cleaned periodically. One good way to do this is with a swimming pool vacuum cleaner. Alternatively, you could install a tank vacuum system. This is simply a pipe which acts as a siphon when the water level in the tank reaches a certain level. The pipe, through siphon action, sucks up and expels the water from the lowest level of the tank, including the layer of sludge at the bottom.
Hygienic management of the workplace during maintenance is essential to stop recontamination of the treated water and to maintain the hygienic integrity of the reticulation system. After maintenance, the system ought to be reconnected, then pressure tested, flushed, disinfected, and then samples taken to test for bacteriological quality. It is essential to disinfect the pipes
And tanks.
before placing the system back in service.
After this, the pipes and tanks can be drained and filled with drinking water. After 24 hours, if the bacteriological test is clear, then you may bring the system back into use.
We can't stress it enough, the responsibility of the small supplier to manage the reticulation system. It's really, really important, because keeping the water clean throughout the storage and distribution process is as important as getting the water clean in the first place.
Maintaining the effectiveness of the reticulation system, ensuring it is sealed and safe, that water pressure is maintained, that maintenance is done in such a way that recontamination cannot occur is important. The reticulation system needs to be designed while keeping in mind the type and availability of source water and the needs of the community for whom the water is being provided. Pressure management systems, whether by pump or gravity, and backflow prevention devices should also be chosen to suit the needs of the reticulation system. As a small water supplier, your responsibility doesn't end with getting the water clean, but with storing and distributing clean water until the water comes out of the tap.